Thanks, Doug. Hi, everyone. I'm Zoubin, and I lead the Google Brain team at Google Research. I'm thrilled to talk to you today about our research in AI and language. My personal journey in AI and language research started in the late 1980s. It was an exciting time to work in neural networks back then, but we were very limited in what we could achieve. For example, even though I was using one of the most advanced computers at the time, a connection machine that you can see here, it was nothing compared to what's available now. And it didn't help that the World Wide Web didn't even exist yet. Technology in AI has advanced a lot since then. At Google, helpful technology grounded in research is in our DNA. In fact, what began as a research paper about information retrieval would eventually become the foundation for Google Search. We've come a long way since this paper, but our approach to research has been the same: to focus on groundbreaking research that can improve the lives of as many people as possible. There's no better example of this than our commitment to advancing AI through language. Language is at the heart of how we communicate with one another and understand the world around us. And that's why it's important for us to push the state of the art in language-based AI. Let's take our latest and most capable model, PaLM, as an example. We announced it earlier this year at Google I/O. And since then, we've made significant progress in AI research building on PaLM. For example, we introduced Minerva, an AI system that's built on PaLM and trained on scientific papers. It has the extraordinary ability of solving complex math problems, some at the graduate level. It does this by learning to do symbolic and arithmetic reasoning by discovering patterns in thousands of published papers. We've also explored using PaLM to make robots more helpful. A lot of today's robots exist in industrial environments and are coded for very specific tasks. To make robots more generally useful, we recently combined the natural language understanding capabilities of PaLM with the real-world capabilities of a helper robot. The result is PaLM Seikan, a robot learning model that gives a robot the ability to execute complex and abstract tasks by tapping into the real-world knowledge encoded in PaLM. We've expanded on this work recently by exploring how robots make sense of what they see through language and can even use that to generate their own code in real time. These examples show the pace of innovation today and how far we've come in such a short amount of time. If you take a look back at 2017, when Google developed the Transformer, the world didn't know it then, but this model would become the foundation of nearly all of today's advanced models. This includes some of our most advanced language models, such as PaLM, and even the generative AI models you just heard about from Doug. By continuing to make language a fundamental part of our AI research, our hope is that it will benefit everyone in more ways. As we look ahead at the next generation of models and their impact, it's important for us that they reflect the diversity of world languages. There are over 7,000 languages spoken around the world, but only a few are well represented online today. So if you're one of, for example, the 100 million people who speak Swahili, a language for which there is not a lot of text on the web, it can be very frustrating when technology doesn't work the way you need it to. If we want to provide AI-based language technology for the world, we need to make sure our models are also trained on representative content of the world. At Google I/O this year, we announced support for 24 new languages in Translate, bringing the total to 133 used around the world. But even then, we know that this is not enough. To this end, I'm excited to announce the 1,000 Languages Initiative, an ambitious research project to build a model that will support the top 1,000 languages of the world. To accomplish this, we'll be focusing on 3 important factors. First is multimodality. The way people access information and connect has changed since the early days of Google. They're moving from text to relying on other modes like speech. Our models have also come a long way since those early days, too. Many are capable of processing language-based information directly across multiple modalities, such as speech and videos. To make our products even more accessible, it's important that we address interactions like speech and other modalities. To this end, I'm delighted to also announce that we're building a universal speech model that's trained on over 400 languages, the largest language model coverage seen in a speech model today. The second focus for us is to continue to engage the broader community. We recently announced support for 9 more African languages on Gboard by working with researchers and organizations in Africa to create and publish data. To build on the universal speech model and feed future efforts like this, we'll continue to work directly with communities across the world. For example, in South Asia, we are actively working with local partners to eventually collect representative audio samples from across the region's dialects and languages. And we are spinning up similar efforts globally. We also want to engage with the broader research community. And we'll be publishing a paper in the coming months so our research colleagues can build on this project. Finally, we plan to improve our products like Gboard, YouTube, and Translate by increasing the number of languages these products support, making it easier for people to use technology in their native language and to find relevant content. This will be a multi-year journey, but this project will set a critical foundation for making language-based AI truly helpful for everyone. Now, I'd like to turn it over to Marion and James to talk about how building AI responsibly for society underscores everything we do. Thank you.